title is Mini Weather Station. Our group consists of 3 students, myself, Neil Mehta, Krushav Shah and Vrushab Shah. We all will be taking part in explaining the virtual mini station. This project was done under the guidance of Manish Bhelande sir. So let's get started. So this is the circuit that we have done on the Fritzing app. This project is Arduino based mini weather station with Wi-Fi connection, which is enabled to post data publicly online using the ThinkSpeak platform. The aim is to make a small and simple weather station. The weather station collects the data related to the weather and the environment using different sensors. The sensors that which we are going to use today are: for temperature and humidity, we use DHT22 sensor. For dust concentration, we use PPD42NS sensor. For light intensity, we use the grow light sensor. For ultraviolet rays, we use GUVA S12SD sensor. For atmospheric pressure, we use the BMP085 sensor, and the Wi-Fi module we use to connect with the internet is ESP266 sensor. We all will be explaining sensors and its connection to the Arduino board and breadboard, followed by the code explanation and the same output and the sample output. Sorry. So let's start with the sensors. The first one is DHT22. This is a low cost digital temperature and humidity sensor. The sensor has a ground pin which is connected to the breadboard, a data flow pin which is connected to the D2 on Arduino board, and a VCC pin which is connected to the breadboard, which will provide the power to the sensor. It requires a pull-up resistor to function properly. The resistor needs to be situated between the VCC and the data pin. The next which we will be discussing is the PPD42NS, the dust concentration sensor. This is a low cost particle counter. It measures the PM level in air by counting low pulse occupancy time in a given limited period of a time. It consists of 5 pins, out of which we use only 3 pins. The ground pin is connected to the breadboard. The power pin is connected to the breadboard as well. It requires a 5-volt power, and the data pin is connected to the D8 pin on Arduino board, which will help in getting the result. The next sensor that we will be talking about is the groove light sensor. It generates an output signal indicating the intensity of light, measuring the energy that exists in a narrow range of frequency. It consists of 4 pins, out of which we use 3 pins. First is the ground pin, which is connected to the ground port on Arduino board. The second is the VCC pin, which is connected to the 5-volt port on Arduino board. And the third is the SIG port or SIG pin connected to the D7 port on Arduino board. The next sensor will be explained by Krushav Shah.
Yes, thank you. So for measuring the UV sensor data, we have used the GUVA S12 SD sensor. It is used to measure the UV index, which provides a scale to determine how intense the rays of the sun are, and it helps us to determine the proper protection we might need for these harmful rays. The 3 pins that are used are VCC, ground, and SIG. The ground pin is connected to the breadboard, VCC is connected to breadboard as well, and SIG is connected to A0 port on Arduino board. The next sensor will be explained by Rushabh Shah.
Yes. The now I will be talking about the sensor BMP085. BMP085 is a sensor from BOSCH used for sensing barometric pressure and temperature. The device is designed for high precision measurement and low power consumption. The 4 pins we are going to use are ground, SDA, SCL, and 3v3. Ground pin is connected to breadboard. SDA pin is connected to A4 port on Arduino board. SCL pin is connected to A5 port on Arduino board, and 3v3 pin is connected to a resistor, which in turns connect to 3v3 port on the Arduino board. It requires this resistor to function and give accurate result. The another sensor I'll be talking about is ESP8266. The ESP8266 is a low-cost Wi-Fi microchip with full TCP/IP stack and microcontroller capability. This small module allows microcontrollers to connect to Wi-Fi network and make simple TCP/IP connection using hash style command. Out of 8 pins, we are using 5 pins. Ground pin is connected to the breadboard. GPIO I01 general purpose input output 1 pin is connected to D11 port on Arduino port. GPIO3 pin is connected to resistor, which then connects to D10 port. Pin number 4 has two function chip, power enabler and power down. It is connected to resistor. The resistor is a bridge which connects pin 4, and pin 8 is the power pin. Now Krusha will be explaining about code.
Yes. So the code we are running in compiling in Arduino IDE. First, we include all the libraries required for our program. The next thing we do is we define the SSID and we replace the required digits by router SSID. The next we define pass. The next we define IP of the thingspeed.com. Next we do is initialize the variables with different data types which are required. The next is the void setup. The void setup is used to initialize and configure the Arduino pins and initialize the pressure sensor. We use the basic if loop for detecting if the sensor was detected or not. The next is communication with the Wi-Fi module. We use this if loop in this connection of communication with Wi-Fi module to determine that if a connection was successful or not. The next we do is we connect Wi-Fi router. The next we have is the void loop. We measure the dust particles with the help of a formula, that is low pulse occupancy equal to low pulse occupancy plus duration. In this, we initialize the 30-second cycle. We use the if loop to determine the start time and the sample time. Uh, the next is we read other sensors which are required and which give us the required data accordingly. In the same manner, we have used different data types and different loops for that. The main thing we do is we convert the sensor values to string values, which is required for us to understand the output. And then we send the data to the TeamSpeed platform, which will show us our desired output. First, it waits for the sampling cycle, and the next it when it gets the sampling cycle, it initializes the new cycle, and the final data is sent to the TeamSpeed platform with the help of different commands, and we set different fields for different features like temperature, pressure, humidity, and UV, and then we monitor the output of our project. Thank you.
So this field charts show us the output in the graphical form. These field charts will be showing us the highest humidity in the first field chart. As we move the cursor, we can see the high points and the low points, on which when we place the cursor we can see the date time on which humidity was high and low. There are several another field charts that will be showing us the same things regarding about the our weather station. So in all of them, it's common when you place it over any point on the graph, it will be showing us the date time on what day, what was the condition of our weather. So this is a sample data of the Mumbai city. Thank you so much, sir.